All right, welcome to the stream. So my name is David, and I do these like live coding Rust streams. We've done a couple over the last few weeks on GraphQL, and so today I thought it would be fun to try something a bit different. By the way, if you want to catch any of my previous streams, they're all on YouTube. You can find the link in the Twitch description thing. So basically, I need for a personal project of mine, I need some translation INTN stuff, which is basically like you have some configuration file of keys and then some string that they map to, and then you have one of those for each locale. Let me show you. So like the project that I'm mostly used to is Ruby on Rails. And I basically want to build something similar to what you have in Ruby on Rails, but still a bit different. So what you do in Rails, let me show you, is you have these, like in the case of Rails, it's YAML files. I think we're just going to use JSON, and then you just have the locale, and then the key, and then the text that it maps to. So that's pretty straightforward. And then you have this, they have like a method called T that then takes whatever key, and then it gives you back the translation for that key. Let's see if we can find it. And like that the T method is just a shorthand for translate. Yeah, so they have translate, which just takes a key and then returns you whatever string that might be. And it also supports interpolations and stuff like that. So this is sort of what I have in mind. I know there's a thing out there called getText, which I've never used. I think initially we're just going to use this like key-based setup, and we might look into what getText is if this library is successful. But basically the idea I have is to actually make it some sort of procedural macro that will generate the code for you, because I found this library, RITN, which looks cool, but there's one thing that I don't really like about it, and that is that when you actually do the translation, you provide the keys sort of at runtime, right? Which means you might have typos here. You're not really sure if this key actually exists. And I have actually in my day-to-day development had several instances where I just typed the wrong key, or I used the wrong name for some interpolation or whatever. So the thought I had was for each of these keys, like generate some type, some struct that then had methods for each of these keys. And if there were any interpolations within the string, it would just automatically become arguments on those methods. So instead of saying like RICN.t introduction, you just say like dot introduction or something like that, and then that's a method that then returns this string. So that's basically the idea of the library that I want to make. And then it's mostly just going to be an experiment at first, but let's see where it takes us. And I also thought it might be fun to sort of see what it's like to actually develop a crate from nothing, basically. So hopefully that makes sense. If you guys have any questions, just post them in the chat. And otherwise, I think we just need to get started. So since this is going to be a sort of mostly a procedural macro, I have this is the other project that I've been working on until now, Juniper from Schema, which is a procedural macro for doing GraphQL stuff, but we're just going to be stealing like most of these dependencies from the cargo file. But first, I think we should just like start making a spike and just sort of experiment with what code we would actually want to have generated. Let's say cargo new library. Let's just call it ITN spike. No, just ITN. And then we can just start making our first test. Spike. I just need to like see what my editor setup actually is, and if we can actually run these tests. Oh, for some reason they don't run. I guess we don't actually need the test directory for now. We can just do it all in here. Yeah. So what I was sort of imagining was that you would have some struct called ITN keys maybe, and it had like methods for each of your strings. Let's say that we have so if we go with like the JSON sort of style, we might have a hello world or just hello that then is hello world. And let's say this is in a file somewhere called en.json, and then we might have one for Danish. And so then I would want some way to like provide both of these locales to our macro. But first of all, let's just try to figure out what code this should actually generate, and then we can write a test for that. So I figure we're going to have a method called hello. Returns a string. Something like this. But we need to know the actual locale, right? So maybe we need some kind of locale type. And then we say match locale. And I made a quick typo. So like something like this is sort of what I had in mind for each of the strings. And then if you have a different string, maybe with an interpolation, something like this, that would then look like this. So this is basically what I'm thinking that we have to generate. So like for each of the files that we provide, you generate this enum with each of the cases. And then for each of the keys, you generate these methods that all take a locale and whatever interpolations there might be. Does that make sense? I suppose we could even have this be like a static string. But it might be sort of annoying that like the methods return strings of different types, because in this case it needs to be an actual string. It cannot be static. Let's say it just returns strings for now. Why is there a block? What's going on? My Vim is a bit funky sometimes. I'm not quite sure what's going on. Yeah, so let's just try and write a test for this. Let's comment it out and just write like the very first sort of test for it, just to see if our spike actually works. And then I figure that we can take that test and at some point turn it into an integration test with actually generating all this code. So let's say that our locale is English. Let's just call it ITN. Probably need to borrow the locale, right? So we're just sort of commenting in the code like as we need it. Oops. Any complaints that it's not implemented yet? There we go. Let's do the one in a different locale as well. And I made a typo somewhere here. There we go. Then let's just get the interpolation thing back. Whoa, what the hell did I write here? Greeting. That was a bit too fast. So I guess here is a bit annoying to always take a string because we might just have a slice. Now there is that, I can never remember what it is. There's that like as ref stir. Something like this. And then this is a T. You probably need to use as ref, right? Oops. Because like we could use into as well, right? But then that would, like if we gave it a slice, then it would allocate, which is not necessary, if I'm correct. I suppose you could also just always take a string. And then if we had like a capital S string, then you would just do that in front. Is that the best way to do it? Let's do that for now. Not yet implemented. There we go. So this sort of works, right? We can at least do this. So now the question is, what sort of macro do we actually want? Actually, let's move this into its own test file. And then, like, as we implement more of the library, we can just sort of remove the parts of this code that's like hard coded and replace it with the actually generated code, right? Tests. You don't need external create, right? Is that all you need? Let's see if it also fails. Great. So that works. Okay. So before we begin hacking on the actual macro itself, I am just going to bring over a bunch of these things that I have learned that you need, just so we don't need to look up the specific versions of all these things. I believe all this stuff is in the Rust book if you wanna see it. And then you need great, so that works. What should we call our macro? So this is like the thing that you would actually call something like this, right? I guess, like, what if you just had all these files in the same folder? So in like locales, and then the macro was just like locales. So you like provide the path to the folder, and then we just load up everything in this, like all files in these in this folder, and then the names of the files will become the names of the locales. I guess that makes sense. ITN. I'm just looking, how did we actually like generate code before? Token stream. Okay, so this seems to at least be one way to like return Rust tokens from a function. So basically, for those who aren't aware, for those who aren't familiar with procedural macros, how they work is it's basically a special function that you like that you put this attribute on, and that just tells the compiler that like it needs a token stream and it returns a token stream. And you can basically think of these as like Rust code, basically. So like we can then put Rust code in here, and that will just somehow get parsed and like turned into data structures, and then we can return that at the end. So this is basically the stuff that we're going to be building up over time. So yeah, let's try to get that to work. We probably need to use it. That works. And then let's see if we can just move all this in here. And that works as well. So we're successfully like taking this code, spitting it out, and actually putting it in here. And just to make sure that we're doing everything right, let's remove this function. It should fail now. And it does. Awesome. Let's put our locales in a folder. Say tests. Locales en JSON. Let's make another one for Danish. Whoops. And then say that our locales are now in tests locales. And I figure that this will be like relative to the crate root. So let's first let's sort of start from the bottom and actually like write a function that can read this and like find all the paths, like all the locales. However, so this input is token stream. I know there's some way of like turning that into a string. To string. You cannot do that, right? How do you do that? Because I was wondering if you could like, so ideally you'd want to put these on one line, right? But here it doesn't know which type to actually turn it into. Whatever. Let's just do this. And let's print it. doesn't show up. Alright, so it contains the quotes. I remember that from doing this before. So we can just remove those. I believe that is how you do it. Yeah, so now it's just like a path. Now we just need to find the relative path to the crate root. I believe there is a macro for that. I believe that cargo sets an environment variable for the location of your cargo home. Cargo manifester. Yeah, so this is the full path. I suppose that could also be like that, right? There is some macro that like inlines an environment variable at compile time. Env. Is it just env? Yep. Cool, so what we need is just like smash these two together. Let's do it the right way. Path. There we go. So we're now able to successfully like find the crate root, which is this stuff, and actually join it with whatever input you gave here. Cool. So now let's think about how do we actually write a test for finding like each of these files, right? What if you just have a function that takes whatever input comes into the macro and then returns a list of files or something like that? Because that we can easily test. So let's do that. Let's uncomment this stuff. And so I figure we would some let locale files be find. Oops, what the hell? If I could use Vim, that would help. Or parse input. No. Say find locale files on the locales directory. What if this instead just took the input? That would make it easier for us to test. Otherwise, in the test, we'd have to do stuff like this to actually find the directory. Yeah, so let's write this function, and it will return some sort of vec of path or something like that, which we can then read. Read each file, turn it to JSON, and then operate on it from there. Yeah, let's do that. Finding locale files. And so I often like to write my tests sort of from bottom to top. So if you start with the assertion, I will assert that locale files equals The question is, does it return each name of the file or the full path with all this stuff in front of it? Let's just return the files for now, and then whatever method actually reads and parses those files, we'll just have to get this stuff as well, which I guess is fine. So now the question is, where does this come from? quite sure what that was about. Something with the path type. The question is this just a string or is it a path buff? We could also do the same thing that join does. I guess that makes sense in this case, right? And now path buffs cannot be compared to strings. That makes sense. There we go. Not yet implemented. Okay. That makes sense. So I guess path buff is what you want to use in this case. I like taking small steps. So this stuff still works. Then how do you like read all the files in a directory? Is there something like that in the standard library, or do we need to like glob for it? Read dear. I guess this is what we want, right? An instance represents an entry inside a directory on the file system. Each entry can be inspected via methods, blah blah blah. File type. What's that? This file is dir. Yes, let's just do that. I'm not super familiar with this API, so we're just gonna see what it gives us. It just gives us the directory. Why is that? What the hell is this? That looks funky. Read dear. Is that because it returns a result, which is iterable. So you need to do this. Yes. That's super funny. That's one of those things that you can sort of, at least in the beginning of writing Rust, it's very subtle to get wrong. Because if you look, so what we did was we just iterated directly on whatever this method returned, right? Or this function rather. and it returns a result which does implement into iterator. And I believe it like iterates over only the success cases, right? Which is why like you only see, like, it looks like it doesn't find anything in the directory. But what we need is to unwrap so that we don't iterate over the result, but the actual like type inside it, right? Because now we get both. So then we need to know if it's like a file or a directory, because we don't care about directories. Entry. Let's iterate. Does it return options? It does. Entry. You should really return a result from that function or define it only for tests. But like this function will be called by the macro. And if it doesn't work and we can't read the directory, then we just kind of have to crash, right? There's really no way to handle that failure, I think. Whoops. But yeah, you're totally right. Like these unwraps are a bit dirty. But I'm not sure that returning a result would help a whole lot. Because we'd eventually just like in our macro here, if we return a result, we just have to like unwrap it or panic if there is some exception. We can't really handle that. Well, but I guess, but can you return a result from a macro? Can you do that? Is that what you're saying? Oops. The macro it expands can. I'm not quite sure what you mean. Like we need the file path, otherwise we can't do anything. Path. So the readdir returns this readdir iterator that is an iterator over dir entries, which when you run thing bang, it can expand into something which is a result of the code, which would be in a successful token stream. But you would still just do the unwrap in the like macro function itself, like at the top. Which means that all you're basically doing is propagating the error up, and you're just unwrapping at the end anyway. You're not actually handling it. I'm not quite sure I'm following you. But we definitely only care about files, not folders, unless we want to like go recursively into folders, but let's not do that. Let's just say that we don't allow any directories in there at all. Yeah, but like our macro expands into actual code, so you cannot have an unwrap here if that's what you're thinking. Like our macro doesn't expand into expressions or statements or something like that. It expands into like defining data types and stuff. That's fine, that's fine. But you're absolutely right. If this was like an actual macro that you would call from inside a function, then that should ideally never panic. So that is correct. Oops. We have each of the files. Then we can do something like this. This is probably not going to type check because I don't think that. Wait. It also it's the full path, right? So like looking at it again. So that's the full path, including all the other crap. It's technically not Linux, I'm on Mac, sorry. It's close though. Okay, so like the question is, do we return the full path or like just this part? So if we return this part, it's easier to test. But if we return the full path, then the rest is easier to implement because we don't need to keep passing this along. So let's think of a way that, like, let's not optimize for making the tests easy, but optimize for making the actual code easier, right? How would you do that? I guess we need this in our test, right? Oops. I wonder if, like, do you need to deal with all the joining and that stuff? A part of me just want to use format directly and just like put an actual slash in between. I'm not sure if that's the right way to do it. Let's do it the right way. We're on camera and we have to be a good example. So the expected paths are You did. What's it called? this the one? Can you do stuff like this? What does join return on a path? Ah, not for us. All right. This is really annoying. I'm not sure how to get links from the stream, because I'm streaming from my PC. So like my Mac is hooked up to my PC via a capture card. Any format for translations. Yeah, I've heard about nim. That's like, it's like, it was similar to, sort of similar to Rust in the type safety sort of way, right? It didn't do borrow checking, but it was like really like high performance, competitive to C++ kind of thing, right? I just remember I saw a talk about it and how the macros work and how the syntax was like really weird. It's like Python syntax. Let's check it out. Nimterlin. Is that how you spell it? So this is the like the format you specify translations in, I guess. Echo cat. I've never used D. Is it any good? I just came to Rust because I really like all the type safety. I've written a lot of Haskell in the past, so that was, but Haskell's a pain in the ass to use. So Rust was like sort of a more practical Haskell for me. And it's nice that it's fast as well. I write Ruby by day, which is not a fast language by any means. Alright, let's actually try to get some work done. So this works. Does this work as well? Type checks, that's a good start. So what I'm wondering is, can we just I guess we can. Like what I was wondering is, what is the type of path at this point? Okay, it is a path buff already. I was wondering that, because like I noticed before that there was some like OS string thing, whatever. Yeah, I guess I was looking at this method here. Okay. But we did actually get some sort of error. Let's look at it here. We have a bit more space. Yeah. Tests, locales. I suppose we should format that in, right? So now the order is wrong. Alright, that actually passes. Also, you should simply skip directories, or maybe a warning. I guess that's a good idea. Let's make a note of that. Can you do like this? Oh, NeoVim for sure. NeoVim for sure. I used Vim for a couple of years, but I switched to NeoVim, like, I think like 3 years ago, 2-3 years ago, something like that, and I haven't looked back. Like, I know that like Vim has since like copied a bunch of the features, like all the async job stuff, but I've just kind of stuck with NeoVim. It works great for me. I remember I read some post about like why they made the NeoVim project and how they felt that it was like one guy who was in charge of the whole thing, and that the code was supposedly a mess. So they wanted to like basically start from scratch and make it an actual enjoyable project to work on, which I do support. I haven't contributed to Vim, so I can't say if it's actually nice. It doesn't have remote plugins. I'm not sure. I honestly haven't even installed Vim 8. I just use NeoVim. It works great. Spacemax. That's that kind of Emacs thing. That's sort of like a really beefed up Emacs, right? Community-driven Emacs distribution. Yeah. I think I've tried it, but I usually don't like these like sort of pre-configured editor kind of things for you. I like customizing my environment over like several years. Like my dot files is pretty big, and I have like a whole lot of plugins, and like this file I've just maintained over years and years, so I know everything that's in there. I sometimes feel that if you get like a pre-made solution like this, you don't really know what is Emacs and what's not Emacs. But I totally get people who want to use this because it is sort of the best of everything, right? And people have made sensible choices for you. Yeah, I've tried not switching, but I've tried Emacs a couple of times, but like after years of using a certain editor, it's just ingrained in you, right? But I watched what was it? I saw this talk, which was basically like an introduction to evil mode and how it's sort of Vim inside Emacs done correctly, right? And like there are certain things in Emacs that I would want, like org mode is something that I would want, but oh well, you can't have everything, right? So this actually works now. What I would like is just turn this into a map instead, right? Map. Back found nothing. Very guys. Yeah, I do the same thing. I have, like, have you heard of the Procedural software? Is this guy who makes like screencasts on like Ruby and testing and stuff like that, and I usually just have that running in the background. He has like a huge back catalog of stuff, so I watched that way too many times. That's also how I got introduced to Vim in the first place. I like Bob Ross as well for coding. Just watching some guy paint happy trees. Let's bring this test back and see what our function actually returns. So it does seem to be working. So now what we need to do is like read each of these files and then turn it to JSON and then make some sort of data structure that represents this that we can then generate code from. And we also need to do stuff like find these placeholders and that sort of stuff. So let's just continue with actually reading the files. For that, we're going to need Saturday for sure. And I can never remember how you parse from stir. And then how do you read a file? Read file. ABBA for coding. I have not tried that. K-pop is good too. Like if you're really low energy and you've had your 5th cup of coffee today and it's not working, K-pop is alright. Nim Twitcher, thanks for the follow. So we're just banging out some code now to actually just how do you read a file in the first place. And fix a couple of typos along the way. I have something that I've been listening to way too much is I play a lot of video games, and the soundtrack for Celeste is like really good. I find that sometimes music with words doesn't work for me. Like I can't code and listen to words at the same time. But this soundtrack from Celeste is really good. Yeah, I just used, so I come from Ruby on Rails, which they just have these like YAML files for translations that look like, they just look like this. And so what we do at work is we just use something like some external service like Phrase App, where you can put all your strings in and you can have external people translate them. So we don't really have people write like those locale files themselves. So I suppose that Phrase allows you to like download your translations in whatever format you want. We just say we would like them in Rails in YAML format. But technically, there's nothing that prevents us from supporting different formats of files, right? Which is starting with JSON because it's straightforward and what I'm familiar with. So did this work? It did. So we're able to read the JSON, which is cool. Then let's think about what do we actually want the code to be. Should it be? I'm just debating whether we want a file that both reads the files, generates the JSON, and makes whatever data types we want. We could also just do something like this, right? I definitely don't want this in like the main file. Let's just put this in its own file and then make a separate file that parses the actual JSON. So we need a test. So what we want is and then we want to read that. What do we want? What do we want? So I guess so in the past, the other sort of procedural macro library thing that I work on is for GraphQL, and what it does is you write like a schema, a GraphQL schema, and then it generates, you call some procedural macro that reads the file and generates a whole bunch of code for you. But what I did here was I just parsed this schema, and then whatever AST came back, I just looped over that directly. And that has its benefits and drawbacks, so I would like to consider if this time, instead of, like, we could just write a function that just loops over the JSON directly, right? But I think it might be sensible for us to have some sort of data type that represents each key and also has data for placeholders and stuff like that. That also makes it easier to test. So I'm just kind of thinking what that looks like. So I suppose we're going to have some sort of struct that has a key and a string for a translation, and then some placeholders. something like that, right? And then we can like parse the JSON and build up a vec of these, and then whoops, learn how to use Vim, and then somehow from these generate code. So if we imagine that we have a data type like this, that means that we should be able to say that keys, the first one, its key should be greeting, its translation should be hello name, and its placeholders should be like that, right? So let's not deal with the placeholders for now. Let's imagine that we have a function called that takes one of these file paths and reads the file into JSON. Let's take small steps here. So you should be able to say locale paths, iter map, and that was exactly what we did up here, right? We're just going to pull that out. And so having that, we can say build keys from the JSON. Or, so this does it for each file. Let's say that we have just one. Then we don't need to do all the mapping and looping. Build keys from JSON. I suppose this does make sense as like a first approach. So you never really know what you need, so I usually find that you just write some code and write some tests, and then as you sort of use it and implement it, you get a feel for what you actually want, right? So we need a file called read file to string. Wait, read file to string. Read file, a JSON file. JSON file takes a path, returns a value, build keys from JSON, that returns a vec of those. Alright, so the first job was just to like basically get the types to check, and then we can actually start implementing it now. So read file from JSON, we had that already. That was just what we wrote before. Test reading files. So So that's this guy. So now we need to actually like iterate over this JSON. How does that look? CRD JSON. It's like an enum that has a bunch of cases for each thing that a JSON can be. A JSON value. So we're only interested in when it's a map, right? If it's anything else than a map of string, then that is wrong. So I suppose what we actually want is we don't want to parse it into a value, but into a hash map of string. Then we avoid having to look at the JSON at all, basically. Like that. Read strings file, or read translations file. I guess. Expected a value, found a hash map. It's because this is now a map. And before we forget, let's just change this. Expect we're gonna spend more time making like actual useful error messages later. For now, it's just getting something that actually works. So now we need to loop over the array or the hash map and build a whole bunch of these. Key translation. Is that it? That passed, and so we actually need to see it with an actual fella. So if we change this, it does actually fail, which is good. Why did it fail though? Left hello, right greeting. That was not the error message I expected. I expected it would say something like, wait, we're not actually testing both keys? Is that why? Hello. That's probably because the order changes. Like the order isn't stable. Let's just take a look. And we need to derive debug here. I wish this macro would just borrow it for us. See, it passes sometimes and fails other times. But it is actually parsed correctly. It's just because the order is wrong. So the question is, where do you do? Let's just sort it in the tests. Sort is how you do it. Slice sort. Sort by key. Yeah, let's use that instead. Then we don't need to derive ord on this guy. It's a bit weird that having to derive that just for testing, basically. Sort by key. Key.key. That's a lot of keys. Why not? Cannot move out of borrowed content. I guess the clone is fine just for testing. Let's run it a whole bunch of times, making sure it doesn't seem to fail. And even swapping these around shouldn't matter, right? Cool. And now if we change one of the keys, it should fail in the way we'd expect. Yeah, so this is the failure that I expected to see. See you, man. Take care. Nuke that. Pass this again. Cool. I think we should get to actually parsing out the placeholders. That might be kind of fun. So we could do it with regexes or a bunch of other things, but I guess the easiest way to do it is just loop over the string. Can you like loop over the string, and then just whenever we see one of these, start like gathering together the characters, and whenever we see an end, just stop gathering, basically. We could write some sort of complicated regex, but at least for this sort of proof of concept, I guess that approach is fine. So let's write a function that just parses placeholders. Test parsing placeholders. So I would assert that find placeholders in this string would give me, come on, that. And the string that has no placeholder should give me nothing. Let's do one with 2 as well. Something like that. Cannot infer type for T. Not yet implemented, that makes sense. So let's say So we have the variable that we like put stuff into, and then we say for char in schars. I know this is probably broken in many ways with regards to Unicode and all that, but well, let's just move on. Let's make like the most simple like state machine you could ever imagine. So let's say that we have some sort of inside placeholder thing. Chars the Unicode characters, that works fine. Good news. Placeholder false. And then let's say if we're inside a placeholder, then we push the character. No, I suppose this needs to be a string, right? Wait, no. No, we need two accumulators. We need one for the vector itself, and then one for whatever string we're building, since we're looping over the characters one by one. Current placeholder. And then if we're inside a placeholder, then we push onto that. And if the character that we're currently seeing is like that, then we say that inside placeholder becomes true. If it is a closing, then inside placeholder is false. And then we set current placeholder back to a string. And whatever string we have now, we push into the accumulator, right? Is that it? And so if we just see any random character, we just ignore them unless we're currently inside a placeholder. I guess that makes sense. Probably not. Because we're forgetting to remove the final, like the closing thing. That is probably because this needs to go down here. I guess the easiest way might be to convert it into an else if. Yeah, that works. That was easier than I expected. I wonder, are there any sort of edge cases that we'd want to handle? What if, like, you only have like strings that are just sort of invalid? What do you have stuff like this? What happens then? You get nothing. I guess that makes sense. And so if you have one that then only has the closing, how should that work? Get an empty thing. That's definitely not what we want. We'd also need to figure out some way to actually escape them, so that if you wanted an actual curly brace inside your string, you could escape by doing two of them, or a backslash in front or something like that. Actually, let's just not worry about this at all for now. Let's make a note for ourselves. about if C is not closing and not inside placeholder? Why are you thinking that we need that? What case is that for? Like, what does that mean? Would that be to handle like the case where you get this to avoid getting an empty thing like this? Is that what you're thinking? Oh yeah, I suppose that does make sense. Not inside placeholder. Should then just do nothing. String. I think ideally I'd want to panic on invalid input so the users know that there's something fishy going on. Because I have seen it work where like marketing people are in charge of like doing the translations, and sometimes they just forget like one of these closing braces. And in that case, I definitely want to know about it, because otherwise it's going to be a bug. So I think I'm going to leave this out, and then like when we actually handle this case, I'll want to make it a panic. And like somehow that has to work with how you do the escaping and all of that. But we should basically be able to plug that into our like the function that builds the keys, right? So the placeholders for the first one should be nothing. And the placeholders for the other one should be name. If I could type. And so here we need the placeholders. And this should be as simple as find placeholders value. I'm thinking if you can like avoid the clone by saying something like this. Indeed. Hey, that works first time. So if we try to actually break it by changing this, it should now fail with the wrong placeholder. Like that. It does, so it is actually finding the right placeholder. There we go. So now we're sort of successfully able to read this file, build up some types that we can use, and actually find the placeholders as well. That is very neat. I'm thinking that this is sort of all we need to build up the locales. We don't really have this dictionary, like this, not dictionary, like list of enums that we would actually need. Like what the names of the actual locales would be. I guess that's the final thing. So that's just the names of the files, the locale files, right? So I suppose we need some sort of function that actually ties it all together, right? And returns a hash map of some sort of like a hash map of like a locale name and then a vector of these keys that we want. The question is, what if the files don't have all the same keys? So what if there's one missing? I guess we could have like a validation step that ensures that like all these all have the same keys. You could also consider having some sort of type where maybe you had a hash map of locale name and the key, and then that mapped to one of those types. But then it doesn't really make sense to have the key be here, right? Let's think about this for a moment. Like, what would be easiest for us when we had to like generate the code? So we need each locale in order to generate this one. We don't care about the keys for that. Here we need all the keys. Like, we somehow need a loop that loops over all the keys that you have. It doesn't care about the locales. And then when you're in like generating the code for the body of the function, then you need each locale and what string it translates into. So we need the locales separately. We need that for the enum. Let's just make a note of that. How do you spell it? I guess in a way this type, is that the type that makes the most sense? Because oh wait, no. We need to loop over all the strings, like each of these lines, and then alright, let's not overthink it. Let's just do this because it's sort of the most like simple thing. Also, if you like look at the files, you would imagine that this sort of is what the files map to, right? Each of the file is an entry in the map, and then the content in that file is just the values in that map. So let's go from there, and then we can see where that takes us, right? So we need, let's just bring that type back. So we need some way of actually finding all the locale names. So I'm thinking that's going to be similar to this guy. Or actually similar to this guy. And then we have something like a locale name should equal some locale name type, like that. from, what do we call it, translations file, file path. Just trying to bang out some types here. Locale name. I guess the easiest way, can you do that? Yeah, cool. So, is this a path or a path buff? Both work. It is a path buff, so there's some deref magic going on. Let's look at what we are dealing with first of all. So what we're gonna have to do is somehow, like, for this path, take just the base name and then like titleize that somehow and remove the extension. Is there a function for the base name? No. File name? Path file name? To path buff. Can we just, because this is defined on path, right? The question is, can we say, can you say .file name directly? It seems like you can. And then that needs, so that's an OS string. String lossy to stir. The file name includes the extension. Is there some way to get rid of that? Strip prefix. What's that do? Strip prefix end with file stem extension. Components. Is there some way to like just remove the extension? With extension, like you can get the extension. File stem extracts the stem non-extension portion. That's exactly what we want. Cool. So then we need to titleize this, which I will use the crate call heck. Or I guess since it is really just uppercasing the first letter, are there any locales that have like multiple words in them? I don't think so. It's just like they're all 2 characters, right? So there's got to be an easier way than, because like I know there's this critical heck which does like case conversion, like camel case to snake case to whatever, and it can probably also like camel case is what we want in this case. But I'm thinking if there's probably no need to bring in this whole library, right? Because all we want to do is just uppercase the first string or the first character. Why is capitalizing the first letter of a string so convoluted? This seems like just the naive way to do it, right? Let's just do it that way. It works. That's good. That works. And so if we didn't uppercase it, it should fail. And it does. So our test is actually working. So that is all we need in order to build up this type, right? That reminds me, in order for these to be keys in a hash, you need to derive EQ, partial EQ and hash. So let's write the test that actually builds this type. So that is probably going to be this one, because we need to get into the directory again. So we're going to find the locales. And then let's just have one function that takes whatever this is and builds this hash map for us. Translations. What do we call it? Build translations from files. Read translations from file, build keys from JSON, find placeholders. guess so. So if we, on that one, we get locale name, that one. So that gives us a vector of these. And then from that we get the first one, which is then going to be the greeting. So we get its key. It should equal greeting. And if we get the translation, I think this is sort of the last of these unit style tests that we're going to need, because this is sort of the last function that doesn't actually generate code. I think from this, once we have this, we can get into actually generating the code. Build translations from file. The function doesn't exist, that's fine. So it had to return one of these. And it takes whatever find locale files returns, which is a vec of pathbuff. And we just have some borrow stuff to fix. Let's work on one of them at a time. I always forget that you need to borrow here. What's it saying? Oops. Test building translations. And this should fail now because it's not even implemented. There we go. So what we need to do is make the hash map. Let's do that first. And then from these from the files, we need to build the, we need to loop over each file, read it, build JSON, make the locale name, and basically call all the functions that we've been using until now, right? That we've been written until now for file and files. So next, so we have the locale name, which we need to be the key. Then we need this vec here. And so the vec that we want is this guy. So we need to somehow be able to call this function, and it takes a hash map of string to string, which we can get by using this file. So we need let's say we need this guy. We need whatever comes out of this one. something like this. And I actually think that is it. That was almost too easy. Let's just uncomment, or rather comment out all these tests and just break like this guy, just like we did before, just to see that they actually can fail. And it does. It expected something without the 1, 2, 3. If we remove it, it still fails. Why is that? Is that because the sorting is not consistent? Oh yeah. Didn't we fix that? We did sorting somewhere else, I remember. We did that in the test. So here we do the sorting. That's really annoying. Because we cannot, like, we could technically do it here, but then you need like mutable access to the vec in the hash. How? This should fix the tests. But like you might have like thousands of keys here, so sorting it is cheap to do the sort, but it is something that I would like to avoid. Let's consider how we can do that. I guess I'm not even gonna try to pronounce that name, but thanks for the follow. What if we wrote it something like this instead? So what the hell is it complaining about? Huh? So that does pass. It should pass every time. It's just sort of weird, right? What I really mean is that exactly one of the entries in the translations hash should satisfy this, right? Let's try and write it that way. Greeting translations iter find. So this is locale and this is the key. So we want to find where the locale is en, and then so that is an array, or a vec rather. That's one of these. And then on that one we want to unwrap and find say into iter here just to stay sane. Wait, this gives us both the locale and the key. What type is this? Yeah, so it gives us a tuple. We don't care about the locale name. Oops. Yeah, so now this we can loop over. And then we want where the key dot key, that's one of these data types, these structs. So where the key is greeting and the translation is hello name, and the placeholders is name. And if we unwrap that, there should be, like, this should give us exactly expected bool. Oops. What if we make this a so this first find is fine because we cannot have any multiple. I'm just thinking, what if we accidentally have multiple that satisfy these? That means we cannot use a find here. It'll just take the first one. So we might not notice that bug. However, using the first find is fine because it's a hash map, so we cannot have duplicate locale names. So using a find here is fine, but here we somehow need to use a filter, right? And then that is what we mean, right? So this is sort of super messy. At least the types have our back. but hopefully it passes. Let's check that first. And it does, and this should not care about the order at all. So basically what we're saying is that there is only one thing in the hash that satisfies this condition. Which means that if we break it, then the test error is sort of confusing. It's just like 0 and 1 aren't the same. It's not quite as clear as this. But I guess that is fine for now. Yeah. Let's actually just move on to generating some code. Actually spitting this out. And then we can always revisit stuff like this later. But at least it does work. And I gotta be honest, I usually don't put as much care into the test code as the actual production code. So if we bring up the integration test, this basically is the same, right? And so all we need to do now is call this function that we wrote before. Let's actually bring that up a bit higher. Because this is like an important function. It's a bit weird that it's far down in the file. So I'm wondering, can you what if we said hello? Yes, this is indeed Rust. Because we need to somehow like do a loop and build up a token stream over time. So can we just do that with a vec, or can you push directly onto a token stream? That would actually be nice. Token stream, prop macro 2. Extend. What does that do? Extend it with some iterator. I guess that is what we want, right? Interesting. So if we extend it with just like exactly the code it expects, does that work? It does. Cool. Because what I did in another crate that I work on, I have this, I build a vec of tokens over time, and then in the final function I combine all those into a token stream. But I think this might be sort of a more elegant approach. You don't need the additional overhead of the vec, which is cool. So that means that now we need some function that like takes a mutable reference to this guy and this hash map, and then actually generates the code for it, right? So let's start by calling this function translations locale files. Hey, Buckhausen, thanks for the follow. Is it like a meme on Twitch to have usernames that are impossible to pronounce and then have just follow random streamers and have them pronounce it? Maybe it was in the beginning. I don't know. Nope. Sorry if it's your actual name. No offense. I'm Danish. My name is weird too. Generate code. So this is the function that takes the translations and then mutable reference to output. Translations. And it needs to be a mutable reference because we don't want to return a new token stream. Because I guess extend doesn't do that. Yeah, it just mutates itself. So basically our sort of integration tests fail now because we don't actually generate any code. So if we say what does this actually look like? Let's start by generating the code for the enum. That's just each of the cases. Let's have a function called let's call it gen instead. We're going to have a lot of these functions. Gen code, gen enum, locale enum. From the translations and the output. We only need basically the locale names, right? I believe you can say .keys, which returns like some iterator over the keys. Keys for key and value. Rust doesn't have any localization in their libraries. You mean in the standard library? The standard library doesn't. There's a couple of like community packages. I just happened to find this one. But the issue with this one is that you provide the keys sort of at runtime. So what I'm trying to do is to basically build a structure that has all these keys as methods so that you can't make typos. And you're guaranteed that your interpolations are correct and that sort of stuff. It's mostly just an experiment. So I was wondering where that keys thing lives, because we need to import it. So it takes a keys, which is an iterator over the keys for key and keys. Are you considering fixing LTR RTL? I don't know what that is. So we need to extend left to right, right to left. Mixed content. I'm not following you, man. Are you talking about the internationalization stuff or something else? Like if you want to like internationalize like Middle Eastern languages that go from right to left, or basically the way this works is you just provide the text. It doesn't care in which direction it goes. So you just say, I want the text for the greeting, and it just gives you back the text that you've predefined. So that should just work. So what we need to do is generate like this enum, right? And it has each of these keys are variants in this enum. And I know that you cannot just like if you like quote this literal locale name, it'll be an actual like string token in Rust. You need to actually turn it into an identifier. And so if we open, I believe that is the syn package that have identifiers. There's a type called ident that you can make like this. And we need to use both of them. That works. Let's just bring the token stream in there. And then I know that, so like this is an iterator. If you say variance, just look at the type, it's like some map iterator thing. And I've since learned that, so the way you like interpolate stuff into normal like macro rules macros that you would write is with these special like dollar variables, right? And the way you do it in the quote macros is with like a pound in front. And so variance is an iterator, which means that we can do, I believe it is like this syntax, to expand all of them sort of separated by a comma. Does that make sense? So if we just sort of check that now the enum is actually being generated, we can say we have a locale and this should actually pass. And it does. So the way that you know it passes is like these variables can actually be referenced. So if we reference something that doesn't exist, it actually fails. So that means that we are sort of correctly generating the code. I'm curious, if we can actually use cargo expand to sort of inspect our output along the way. That might be fun. Usually it's a bit hard when you're writing these macros to actually get an idea of what you're generating, and sometimes you get some weird type errors that's just simply because you generated the wrong code, right? How does this work? Can you expand tests as well? Options, test. I guess we can't work on expanding it until we actually have the whole thing compiling, though. What I do believe we can do, if we want to look at it like halfway, is I believe you can just print the output like this. I believe it does turn into a string. Yeah, so this is what the code looks like that we're actually generating. So I'm just gonna leave that in for now, and then we can like look here if we need to debug stuff, which we probably will. So we have the enums now. Now we need to generate this actual intn struct. Yep. And one thing that I have learned is that it's neat if you either put documentation on this guy, or if you say allow missing docs, because someone might in their own package have deny missing docs. And so you don't want your generated code that they can't get to fail their build because you forgot to generate docs. So don't want that. So now let's say that we want gen itn struct, and it needs all the translations. Right? Or I guess it needs the translations because it needs all of these, and it also needs all the enum names, which needs to be like identifiers with this locale path in front. So what I'm wondering is if we would want to return something from here so that this function doesn't have to like do all this identifier stuff as well. Actually, first of all, let's pull that into its own function. And then this is like that. So can you return it? No, I think we're not going to do that, because as we're looping through this guy, as we're looping over this hash, we will need to like look up these locale names, like the keys as we're looping. So I don't think that we're going to be able to directly use these names. I think we're going to have to generate them again, probably. So what we need is some sort of extend thing again, right? Where we generate the struct, pub struct, and then we need to also generate all the methods. So now it's complaining that there's no associated function or item for this type, which means that the type actually does exist. We can also see up here that we are generating the code for it. So let's say that we can somehow, just expand all the methods. And so the methods are then, see, this is where like our hash map data structure is a bit annoying, because if we loop over the locales, what we basically want is that for each key, for each locale, what are the strings? How do you do that? Because like we need somehow to loop over the function and get, or over the hash map and get all the keys out together with all the locales. Yeah, for those who've been watching for a while, this is what I was talking about. This data structure is not optimal for what we're trying to do, or basically what we have to do, right? Let's see. Okay, let's take it one step at a time. So we need all the, what is the actual data structure that we want? So we want all the keys. So let's say that's some sort of a vector. Keys of, and then we also need we need to be able to look up, we need to loop over all the keys, and then for each key we need to be able to loop over each of the locales, and know what the translation is So let's say this is a hash map, because we actually need the names of the strings, right? Like the keys. So we need to loop over each of the keys, and then for the key, for each locale, what is the actual translation and the placeholders. So this is sort of the data structure that we need, right? So for each locale name, no, for each string, let's just call this key. For each key, what is, and for each locale, what is the translations for that particular locale, and what placeholders are there. So let's work on a function that actually builds this data structure. I'm going to do what we've done before. I'll comment out all this. It should now pass, or the code should compile, and the test should pass as well. They do. And then let's figure out how to actually write a test for this. So it is similar to this guy, right? I guess what we really want is to actually not generate a hash map like this in the first place, right? Because it's sort of annoying that we build this, we never really use it. All we use is to get the list of locale names that we get up here. And then we patch it to this function, which then immediately changes it to something else. That's sort of silly. So maybe we can consider changing this function to be something else. I am, however, going to make one optimization first, and that is making actual types for these. So this is key. Let's say this is a translation. That just wraps a string. And so here we need to say key is key of key. Like that. And we need to derive debug on both. Because the trap that I want to avoid is, like, I want to make it really clear what each thing is in this data structure. And just, if everything is just a string, I find that that gets very hairy fast. And in Rust, we don't pay anything for making these sorts of wrapper types, right? It's complaining that we're not implementing clone. Which we need here. Or it is not implemented. So I could of course, on this key type, I could of course derive clone and ord, but doing that just because I need it for testing feels sort of dirty, right? But now all it's complaining about is that you cannot do equals equals, which is fine. You can just say, oops, 0, 0. And the test should still pass now. And they do. So now we can be a bit more sort of specific about this hash. So this is an actual key, and then this is a string of translation, or rather a hash map of locale names, so translation and placeholders. We could also make this guy its own type. Let's do that just for clarity and consistency. Placeholders. And we need to update some of our tests. So having to do stuff like this in your test is sort of the price you pay. I believe you can also just implement deref for each of your types. That should also fix it. But we don't really need that for our implementation, at least not yet. If we do, we can just add it. But again, I don't like adding stuff like this just for testing. So this means that this type now is basically the type that we need is this. So we're going to be breaking this stuff. So let's just hide it all for now. And then we can actually write a test for it. Let's just bring the type down to remind ourselves. So what is it actually that how would we test this? So say that we have some translations hash like we've had before, and you look up the greeting key, and so the greeting key then returns a hash map. So then from there, you look up the locale name, en to string, and then if you get its translation, that should equal hello name. Right? Let's just see if the types even check. So you should be able to do something like this. I'll uncomment this test for now because we're going to be breaking a whole bunch of it and probably deleting that test altogether. Cannot index into a type of hash map key. So key will have to implement hash because it's a key here, and locale name already implements hash. Actually, it'll have to implement all of these. No field. And so if, yeah, right, so this returns a tuple. So if you get the first one in that tuple, that's the translation, and then we get its contents, which I believe you need to do like this when you have nested tuples. So this is kind of hairy, but this is only really something that we have to do in tests. Once we actually loop over it later to generate the code, it should be pretty straightforward to work with. So now we just need to actually build this type. And so let's say we just build it from the locale files. That function is obviously not defined. What's it called? Build translations from files. Takes wait a second, we actually have that file already. Oh, that function rather. Right here. And it should return one of these like super hairy types. Locale files not found. There we go. So let's make a type alias for this, otherwise we're gonna go crazy. Type translations. So the types pass, but the tests should not. No entry found for key, that makes sense. So the first thing we need is to actually get out all the keys, right? So the way we did that before is we needed So we could build keys from JSON. That returns a bunch of these guys. So then this is the question of what when the files, they don't contain the same keys. What do you do? I guess this function needs to change too, right? Because we basically have no need for this IT9 key type. We're actually just, we could no, I still think it does make sense to have, because like from parsing, so our original like hash map of locale to these keys does make sense from like a file system point of view. But I think it does make sense for this function to actually perform that mapping. So just so that we can remember, let's say this is a vec of those. Found reference. Build keys from JSON. So this takes one file. So what this is actually is for each file, there's a list of keys, of course. Do we want to like we need all the keys, so do we just read all the files and then make a set of all the keys? We still need to keep track of the locale. You know what I'm thinking? I think that we should just build up some sort of type that is a vec of locale name, and then one of these types. And then we just have one of these for each locale. And I think that's actually going to be easy to work with, because then we can loop over that and then like get out all the keys, turn that into a set, and then loop over that set and then build this final thing. Yeah, so let's do that. So we need, if we loop over all the files, let's start with just having this be put the types there. So this returns a vec of these. And then, so that is keys for file, keys in file, and then we need the actual locale. Like that. It should type check, and it does. So now we need basically this guy. Which means that we need to return an array here, or a vec, so this needs to be a flat map. Why is it saying that? It's not an iterator. Alright, whatever. So this is a vector of IGN keys, so we need to loop over that and combine each of them with this. And clone is not implemented for a locale name. Closure may outlive current function. It's annoying that you have to basically collect the inner thing there as well. I thought you wouldn't have to need that if you used into iter here. So it's still an iterator over own things. Interesting. Not sure why that is. But now we have one of these, so now we can build up. Let's see. Now we can find all the keys. So wait, what was I thinking? Translation, placeholders. Yeah. So we can loop over this, and then we can somehow put that into this hash map. Let's just say this is translations. We can always clean this up later. And so for locale name key in keys, then we want to say insert something at key. And this thing needs to then be one of these hash maps. Wait, this isn't, no, this is annoying. It's sort of like we need two things at the same time, right? We need, so if we loop over all the keys, you know what, I'm going to take a quick toilet break and then we'll be back. All right, we're back. Whoops. Where were we? So we need to, currently what we have is each locale name, it's like each key, each pair of, like for each key in each locale, what is that key's translation? So let's start by just building up a hash map of all finding all the keys. Key. I'm thinking that this is going to be like some sort of something like this. Now we have all the keys. Now, like, we could do a thing where we loop over all the keys, and then for each key we find the particular entry in this vec where the key is the key. Well, we loop over each key and each locale, right? And then we find all the keys where, like, that particular key, where the key and the locale match, so the particular entry in this vec. And then we stick all that in a hash map and then build this type up. But that means that we're going to have to keep looking through like this type and just checking for where these things make sense. So this type is definitely not optimal for that. We would rather have a hash map of that, right? So a hash map from key to well, a hash map from locale name. Basically, like, this, right? The issue is, though, that how do we make this? And it's sort of very similar to this in a way. Or is it? The question is, can we make that type? We can make it fairly easily with what we have currently, right? So we need to return, so since we're doing a map and we want to collect that into a hash map, that means that we need to return tuples from our map. So something like this. And so this needs to be key translation and key placeholders. And then this needs to be the locale and key.key. I think that should work. Except that we have a syntax error somewhere. So now, is this then... So now what we sort of want to do is pull each key like one level out, right? We're sort of close to this. We have this. Can we do a... Let's try doing the map again. This time, this is what we want to come out with. So what we get here is we get the locale, locale name, the key, and the translation, placeholders, so we need to return something like the key and then some map, right? And this map needs to have this type. It kind of doesn't work to do a map, right? It kind of feels like we have to do a for loop and then use an accumulating parameter or like accumulating variable that we then iterate or mutate rather at each point of the loop. Because in order to build up such a hash map, you need like this hash map contains sort of data that's currently sort of distributed across, right? because you need each pair of these tuples in order to build up the hash map. But for this one iteration in the map, we only have one pair. Like, we have the locale name and we have this second tuple here. But it's almost like that is not enough. Like, we cannot build a hash map out of those. So I don't think this is quite right. Let's instead make it a for-in. Do like that. And then we say we want to then insert the key, and then like we can actually use the entry API on HashMap. That allows us to basically like look for something and then insert if it's not there, and then at the same time get a mutable reference to the thing that we're sort of inserting, if that makes sense. So if we say entry for the key, or insert with, so my hope is then that we can somehow say entry insert the locale name and this can just be this. Doesn't need to be mutable. Alright. So this passes, this like this type checks. The question is, does it work? It actually does. Let's just take a look at the data to make sure. So the greeting in English is hello with this placeholder, and in Danish, hey, Chance Maker Live, thanks for the follow. And in Danish, it's the same. There's still some things that are kind of wonky, right? Because we're not actually guaranteed for these placeholders to be the same. So there is something in our data model that is a bit weird. We haven't actually reflected that they need to be the same. So we need to somehow tech that at some point, I guess. And this looks good too, right? Yeah. So this test goes away now. Did all the others still pass? We had a panic that we can just remove. Alright, so now it passes, and if I'm not mistaken, this data type should be much easier to generate the code with. So let's actually look at where we were standing before. This is a translations. If we say keys, we don't get the locale names. So we kind of sort of need those separately, right? Like we build up all the locale names here. But we don't. Like getting all the locale names from this type is sort of annoying. I guess we need a function, like a separate function that just finds the locales. So it would return a vec of locale name from files. And that does something very similar to this. Like that. So this guy doesn't just take the translations, it also takes the locales. And this now needs to be borrowed. This is probably going to fail a couple of the tests because they are not passing borrows but owned references. 96. Gen code 24. Found reference. Ah. Cool. So all our our code compiles, but our tests over here actually, our tests over here don't compile yet because we're not generating the quite enough code. So what we're missing is bringing this back. This now takes the locales. I think it can probably get an owned reference, or an owned value, I should say. Locale names, locales. Loop over the locales, make an identifier out of the 0th item. Yeah, that works. So previously, you can see the code we're generating now does actually have that locale enum, so that works again now. Now we just need to generate this IETNet type with each of its methods, and that's sort of where, where we got stuck last time, right? So the type we have now here is one of these translations types, which you can see here. Let's just pull that up. And the code that we have to generate, let's actually just put that over here for now. And the code you have to generate is some methods where the key, like the name of the method, is this key here, and then the body we need to use this hash here. So I'm thinking it should be fairly straightforward. So let's say methods is translations iter map key translations for key, and then we want a quote, method name is key 0. I think it will be easier if we just use intuiter here. Expected identifier found hello. Ah, yeah, that's cool, because this actually needs to be turned into an identifier. Otherwise, it's like trying to define a method called like this. That's obviously not allowed. So, and we just need to borrow here. Expected one of 11 possible tokens here. That's because we're putting a comma in between each method, which we don't want. It's like if we were to put a comma here, and that's obviously not allowed. Expected string found nothing. That's because inside the method we need to put a string. So if I say string new, I suspect that it should compile and fail and say that like these, it expected hello world, but it got empty string, which it actually does. Hello world, and the right is empty. So this works. Now all we just sort of need is use each locale and just put in the corresponding string for that locale. and then handle, like if there are any placeholders, handle that somehow. So let's say this is just the match. Locale. Actually, I have that already. Say this is branches. So that is translations for key into iter map. And that is a locale name. A translation, and some placeholders. And so the code that we need to generate is something like this. Locale name. And we need to do the same thing here where we say identifier. And it does pass. That's actually cool. It should fail when we run the test because it should expect some text in Danish but get hello world in English, because we're currently just returning hello world every time. Let's just make sure. Indeed it does. One is this Danish thing and the other is the hello world in English. So let's just change this to be the translation, like that. Stop writing tests, start writing features. That's kind of what we're doing, man. Expected string found reference. Hey, check it out. It actually compiles now. And it also works. Woo! Hey, I'm followed just in time. Crayon33, thank you. So this took like 3.5 hours, and we're now able to read a bunch of locale files and then actually generate data structures like this. To actually like look up the that has methods for all the keys. So that means that if you were to try to like translate a string that doesn't exist, rather than getting a panic at runtime, you actually get a compile time error saying that that is not a thing. Whereas if we go into both of our locale files and we define it, now it actually does work. So this is this is basically the goal that we've been working towards the whole time. So that's pretty cool. Yeah, this is Rust. I'm not sure that it looks like Java. I guess it looks more like C++, and then C++ and Java just happens to look a little bit alike, but like you don't have stuff like this in Java, right? But I get what you're saying. So now what we need is somehow these the placeholders. Expected one parameter. So we're currently generating methods that don't expect any arguments, but the method that we're calling here does, we do pass the argument, so something's wrong there. That's basically this guy, right? So we need to turn this into like the same sort of loop that we did before. And let's say this is, well, we always need the locale. And then this is going to be placeholders. And then this actually needs to be, wait, something. Yeah, so we just need, so in order to generate this like list of placeholders, which is going to be something like quote, like stuff like this, right? Whoops. So some sort of a vector or an iterable of those. But up here so we get the translations for the key, and then we mutably turn that into then we consume it and turn it into an iterator. I suppose, so that means we either need to, because we need the same data structure, the same value for computing the placeholders, but we only actually care about the first one. And this is then the case where, how do we handle when, that we talked about before, where not all of the translations have the same placeholders. Let's just ignore that for now and say that the so this is a hash map. We just need any one of those, basically. So if we say translations for key, if you just need some key from a hash map, how do you do that? I suppose you can say iter find whatever true. Right? That's an option. And then we need, so it's like one of these tuples, and then we need the second one and the second one. And that should be a placeholders, which it is. And then we can say, so placeholders is one of these like wrapper types. So if we get the inner item, iter map, name, place, and we need to remove that. Cannot move out of bar content. Yeah, so what if we just say clone? Seems like that did it. Cannot find type locale. See, this is why we put this in that prints exactly the code we're generating, because like when you get a thing like an error message like this, we don't really have any idea what's going on, right? So let's take this, dump it in here, Rust format it. Why is that a problem? So if we don't do this, okay, yeah, we forgot the identifier thing again here. That should do it. We bring this back. It compiles. Let's see if the tests also pass. And they don't, because we're not actually interpolating the placeholders. That should be pretty straightforward. Basically, we need a different body if there are any placeholders, right? So let's say let body quote. I say if placeholders is empty. Then I accidentally deleted the code before. We need this like format thing. The thing that goes inside is the translation, and then each of these is then the placeholders. There is no argument name. Ah, yeah, that's because we don't actually. Like so what we're doing is just generating a format string like this, which is not quite enough. This is getting kind of messy. Quote. What are we doing wrong? Some syntax error. In the generated code or in like our code? In the generated code. Mm, 1446. Whoops. 1446. God damn it. This comma here. That one. Is that it? It sure was. Hooray. Let's, for fun, just try to put a panic here so that we can see the code that actually gets generated. So everything basically looks good, right? This is sort of what we set out to build in the beginning. And it basically works. This is pretty exciting. So this means that you can sort of have a, like, do this internationalization stuff at compile time, which is pretty cool. There's now, like, there's a bunch of things that we don't handle. The first thing being that we don't handle if there's like errors in these placeholders. We don't handle if there's like some string that's in one file but not present in another file. We don't handle if the placeholders don't match between the two translations. Another thing that I would also like to handle is, I'm not quite sure how to do that, but I would like it to be, currently, imagine if you have a translation that takes like, let's say if this was a first name and also a last name. Then you have just like a bunch of arguments to this method. And you then need to know what each of these will map to in the final translation. You need to know that, like, the first one is the first name and the second one is the last name. It would be much nicer if you could, the same way you do when you use the format macro, if you could just say first name equals and like last name equals. Unfortunately, that is not valid Rust syntax, so we either need to have some sort of struct that you pass in for the placeholders, which would then be different for each of the keys, which is sort of annoying. Like you could imagine doing greeting placeholders where first name is that and last name is that, right? And then generating these, generating these as well, but that's sort of annoying and it's really verbose. I don't know of another way to do it though, besides like generating all of these as macros, because then you totally can. But as far as I know, a procedural macro, so this macro up here, cannot generate new macros. I'm pretty sure that's a limitation. So this is sort of unfortunate, but I'm not sure currently that there's a whole lot that we can do about it. If anybody's in the chat has any ideas, just let me know. But yeah, otherwise, I mean, we're pretty much done. I think what we're gonna do now is like commit and then put the code on GitHub. Then you guys can play around with it if you want. And then we're probably gonna cut the stream here. We've been going for like 4 hours and I definitely need lunch real soon. But yeah, that's pretty cool. The test pass, we sort of set out what we aim to do. I would like to try this with with our translations at work, which we have like a couple of thousand strings, so that might catch any errors that we might have. Why Rust? Just because I like it and I want to like do more of it, and we're slowly starting to experiment with it at work. So this is a library that we actually need. So, and I've done a lot of Haskell in the past, so I like type safety and that sort of stuff, and that's kind of what brought me to Rust in the first place. Let's put it on GitHub. Thoughts on Golang? I've never really used it. Honestly, for whatever reason, I'm not really drawn to it. The simplicity thing that they've got going on, I guess makes sense. It's not something that I feel that languages are too hard to use. That's not something that I've felt. I also think it's really weird that they don't have any generics. But I mean, I have no real. I've never used Go for anything serious. I think I've written maybe 20 lines of Go for some benchmark that I did for a talk once, I believe. Otherwise, I've never really done that much. I've never really written any Go. Let's just do this. But how Go doesn't have generics, right? So can you implement your own hash map in Go? Or yeah, they also don't have the option type as far as I'm aware. So do you have to, you're not forced to check for nil, right? It's not in the type system as it is in Rust. Yeah, so I think we're basically done for today. So unless there's any more questions, I am gonna hang out a bit more on the stream, but we're not gonna be coding anymore today. I think the next stream will probably be early next week at some point, maybe tomorrow if we're lucky. Otherwise, if you got in late and you want to rewatch the stream, I'm going to upload it to my YouTube channel first thing when we're done here. You can find the link to that in in the channel description below. And you're also very welcome to follow if you want to watch any future streams. I also post on Twitter when I stream, so follow me there if you want to be notified. And yeah, otherwise, I think that's it for today. Thanks for all that joined and posted questions in the chat. It's great. Yeah, thanks for watching. I'll see you next time.